Today, when preparing for a totally irrelevant video in my lab environment, I encountered a very strange issue. I created a completely default guest network, but the client cannot access internet. This video is about how I troubleshoot it, what's the direct cause, what's the root cause. Let's get started. First, let me start from scratch, reproducing the issue. At this moment, I do not have any guest network defined. If we check the firewall rule at this time, you can see for guest, there's 0 firewall rule defined. Let's go ahead, create a new guest network. New VLAN guest, change the subnet to, let's say, 40, then VLAN ID 40, and enable the guest network. Pay attention here, allow internet access is default. I don't want to change it. Of course, I want to allow internet access. Then nothing else to change. Add it. Let's check what the firewall rules look like after the new guest network is added. Surprisingly, totally 14 firewall rules are added automatically. From action, there are accepts, drops. From type, there are guest in, out, and guest local. There are different protocols, and they have their own internal IDs. This video is not about explaining the firewall rules for guest network. If you are interested, I'm going to have a dedicated video to explain all the automatically created firewall rules for guest network. Then from a Mac laptop, let me connect to the newly created SSID. I need to input the WPA2 password. Okay, successfully joined. The problem is I cannot access internet. As you can see, I cannot ping the Google address. Now let me start troubleshooting. Because I cannot ping a internet IP address, I want to look into the firewall rules. Under settings, firewall rules for guest, there are 14 default pre-existing firewall rules. Because I was pinging Google address, it was not successful, which means I should check the guest in firewall rules. Again, I'm not going to explain the details about in, out, and local. I'm going to talk about that in my next video. As you can see, there are totally 9 guest in rules. And because the ping was not successful, I want to focus on the drop actions. So I narrowed the scope down to 4 firewall rules, right? Basically, the protocol source part, destination part, those columns, they are not helpful at all. They are showing the same information. Let's start with the description. Drop packets to restricted subnets implies it's for my local network. So this one doesn't seem to be the troublemaker. And then the next one, drop packets to intranet. Again, it's about my local network. So move on. Drop packets to remote user. Even though this description is confusing, I'm just doing a pretty normal internet operation. I don't think the so-called remote user has anything to do with my action. Quickly, among the 14 firewall rules, I can only think, okay, this one caused our problem. So let's see what's the description. Allow authorized and drop unauthorized. Even though the description has allow in it, the action is drop. That's confusing already. And then it mentioned authorized and unauthorized. If you go to the firewall rule, you cannot see anything what Ubiquiti means by authorized and unauthorized, right? It seems we are at the dead end. But if you know how Ubiquiti UniFi's firewall works, you may know there's nothing special. It's implemented using the standard Linux packet filter, the IP tables. So to understand what's authorized, what's unauthorized, and to confirm this one caused our problem, we need to go to the SSH to log on to the router. SSH into UX3 Pro. Let me run this command. IP tables is used to set up and inspect the IP packet filter rules tables in the Linux kernel. Because Ubiquiti's router is based on Linux, it's also using the standard functionality built into Linux. So basically, I want to list the existing packet filter rules. There are a lot of rules listed. To save your time, it's not the scope for this video. I'm going to talk about the details in my next video. So I draw a diagram so you can see how the IP table chains are implemented. Let's briefly start from beginning. So let me scroll up. It has standard input, forward, and output chains. Check my next video to understand what they are. What we want to look at for our particular firewall rule, the allow authorized and the drop unauthorized, is guessed in. So we want to look into the forward. You can see the forward is pointing to the Ubiquiti's forward jump chain. And this is the forward jump. Is pointing to another custom chain, which is called forward user hook. For the forward user hook, it has two chains, one for in, one for out. Here, the in and out mean the same thing as in the Ubiquiti's firewall rule type. You can see here it has guessed in, guessed out, right? Because we want to check this particular firewall rule, so we want to check the guessed in, which means we want to look into this particular chain, as shown in the upper side diagram as well. So this is the forward in user. It has several chains, but most of them are about either WAN or LAN. Only the very last one, it is related to our guest in. Let's keep digging. Okay, here we are, the guest in user. This is the one we want to really look into carefully for this video. You see more than 10 rules here, right? They correspond exactly to this guest in firewall rules in UniFi network controller. And for our particular one, this allow authorized and drop unauthorized, they are implemented using this particular one. For all other firewall rules, you can see the target column. They are either return or drop, so it's already the end of the rule, right? This particular rule is the only exception. You need to look one more step deeper to find out what's the authorized guest user chain at all. So let's keep looking. This is the one we want to check. The authorized guests user chain. It only has two branches or two rules. Either return, which means accept, it's successful, or drop, which means the packet will fail. As shown in the diagram as well, depending on the result of this particular thing, as shown here in the IP tables, is called match set with this name. This is not a IP table filter rule. This is a thing called IP set, which is a helping tool for IP tables. You can check the content using another Linux command, which is called IP set. Before we go to IP set, let's check these two rules. For the successful one, the return one, see here, if the source of the packet meet the requirement for this match set, it will be successful, which means the internet access will be granted. Otherwise, it will be dropped. Apparently, for my particular situation, for some reason, my Apple laptop doesn't meet whatever requirement specified here. Then let's see what's this match set at all. In the right side, let me run the ipset command. The command name is called ipset. I want to list whatever this set is. It's pretty simple. The type is MAC address, and the number of entries is 0, and the members is blank. I believe it's already clear now. A computer is able to access the internet only if its MAC address is within this group, is listed as a member. Because my Apple machine is not listed as a member, that's why the internet access was rejected. In the left side, you can see my packet was dropped. That's why the ping didn't work. We already found the direct cause for the issue. But think about from the other way. I just created a guest network. I simply want every single computer which connects to the Wi-Fi SSID, it should get internet access automatically. So then I'm not comfortable ending the investigation here. Let me keep digging. Because we are talking about guest network. For Ubiquiti, there's a thing called guest portal. So basically, if your computer connect to the guest portal, request the access, and then you are granted the access, then you will be able to access internet. So then let's see how we can add the computer using the guest portal. Let me go to the guest network Wi-Fi setting. See, there's a setting here. It's called Hotspot portal. It is the guest portal I was talking about. Enable it. By default, it is not. That's why when we connect to the Wi-Fi SSID from Apple machine, we didn't see a web page pop up. So now after enable this portal, I expect to see a pop-up. Let's go back to the Apple machine. In the browser, if I try to go to a web page, I will be automatically redirected to this guest portal. It has a big login button, but because I didn't specify a guest portal password, it directly let me in. So now this Mac computer is already added to the authorized list. If I ping a IP address, yeah, it is successful. Now if I go back to the SSH session, let me run the exact same command again, ipset, to check what's the current content for the authorized guests. Okay, now you see there's one member with this MAC address. This is the MAC address for the Apple machine. So it seems at this moment everything works. We are good, right? No, because my original issue is not really resolved. We still don't know the root cause. Why even for a default guest network configuration, I need to manipulate the guest portal. I need to add my computer to the authorized list. Why everything is not automatic, right? To put the other way, why we even have this particular firewall rule? Because for a default guest network, I expect every single client to be able to access internet. That's exactly why when we create the network, remember the default setting for allow internet access is true, right? Then make it true without any unnecessary manual work. So I'm still not comfortable. I did a web search and found this web posting. This is the reply from this user. Even without Hotspot portal enabled, the Hotspot landing page is enabled by default. It leads to the troublemaking firewall rule we found. And then this user mentioned how to remove the firewall rule. So let's do that. Before making any changes, this is what we have for guest firewall rules. We still have 14 firewall rules. Then let's go to the Hotspot manager. For the landing page, go to settings. See this show landing page is enabled by default. We didn't enable it. Let's disable it, save. Then let's go back to the firewall rules. See the change? Now we only have 11 rules. The annoying rule, which caused the trouble for this video, disappeared. Together with two other, all of the three, they are related to guest portal. So from firewall rule perspective, it seems we should be okay. But let's double check in the backend. Let me run the same iptables command. Let me find the guest in user chain. Yeah, I cannot find the authorized guests related rule anymore. It's gone. And in the right side, if I run the same command, check the match set, I still have it. And the Apple machine is still here, but see the reference is 0, which means, okay, even though we still have this match set, it's not used by any packet filter. So it doesn't matter whether the Apple machine is in this group or not. it doesn't change the result. At this point, we are completely clear about the situation, about the direct cause, about the root cause. This is the end of the video. So my opinion about this particular issue is I personally think it's a bug because, as I mentioned in the network setting, I allow the internet, then I expect the internet to be automatically working. But I need to do something to manipulate the landing page for guest portal. But the fact is the web posting I found was posted 3 months ago. Till today, Ubiquiti still hasn't changed this. It seems to me Ubiquiti doesn't think it is a bug. Maybe very soon Ubiquiti will change it. Let's see. But at least it's not convenient for my use case. Okay, thanks for watching.